Today we're going to look at if-then statements and their converses, which is a very important part of geometry, especially as we get into writing proofs. Sometimes we refer to if-then statements as conditional statements or conditionals, and the basic setup is if P, then Q. So P is the hypothesis, so that's what we're starting with. We're saying if something is true or if something happens, then Q, which is the conclusion. Then something else will happen, and we'll look at some examples of that. So if P, then Q. So if you look at the statement, if you earn a 98%, then you'll receive an A. So you earn 98%. I'm just going to underline that once. That goes with our P. That's my initial hypothesis. Then Q, you'll receive an A, and I'll underline that twice. That's my conclusion. Notice when I'm diagramming these, I don't underline the word if, and I don't underline the word then. Looking at our next example, it says if today is Monday, then tomorrow is Tuesday. So today is Monday, and that's our hypothesis. Then our conclusion is tomorrow is Tuesday, so we underline that twice. Once we have our true statement, our true conditional, we can look at the converse. The converse of a conditional is when you interchange the hypothesis and the conclusion. So if we start with if P, then Q, we simply interchange them, and then it becomes if Q, then P. A statement and its converses say different things. Some true statements have false converses. So let's look at the statement we looked at earlier. It says if you earn a 98%, so that's my hypothesis, then you'll receive an A, so that's my conclusion. When I take my converse, I simply switch my hypothesis and my conclusion. So you'll receive an A, that's now my hypothesis, and my conclusion is you earned a 98%. Well, we assume that the original statement is true. When I look at my converse, it could be true, but in this case, it's false, because I can think of another grade I could get and still get an A. So instead of earning a 98%, I could maybe get a 94%. So in that case, that makes that statement false. So what I just came up with is what we call a counterexample. And we just need one to prove that something is false. So a 92% would be an example of a counterexample that would make that statement false, or a 94%, any of those. And looking at the next example, it says if today is Monday, then tomorrow is Tuesday. So today is Monday, that's our hypothesis. Tomorrow is Tuesday, that's our conclusion. Now when we take our converse, we're going to switch. So tomorrow is Tuesday, that becomes my hypothesis. Today is Monday, that becomes my conclusion. In this example, my original statement is true, and my converse is actually also true. So sometimes the converse is true, and sometimes, like in the previous example, the converse is false. There are several ways you can write a conditional statement. So the first one is the one we've looked at so far. If P, then Q. Another one, example 2, is P implies Q. So that's a different way you can write a conditional. Number 3 says P only if Q. And the last one, number 4, is a little backwards because it says Q if P. So our hypothesis actually becomes first on that one. I suggest that having these 4 in front of you while you're completing some sample problems will be helpful until you are really comfortable with the material. If a conditional and its converse are both true, they can be combined into a single statement using the phrase if and only if, which we abbreviate with the letters IFF. This statement is called a biconditional. So for example, in our previous statement, we know that if today is Monday, then tomorrow is Tuesday. We also know that if tomorrow is Tuesday, then today is Monday. So because they're both true statements, I can combine them into a biconditional that says today is Monday if and only if tomorrow is Tuesday. Every definition can be written as a biconditional. So for example, if I take the definition of a right angle has a measure of 90 degrees, the converse is an angle with a measure of 90 degrees is a right angle. Now I can combine them into a biconditional and say an angle is right if and only if its measure is 90 degrees.